Greetings, it's M Squared, and we're going to solve some log equations using properties of logarithms. So hopefully you remember those properties. There are three properties that you really need to keep in mind. These are the three. When you have a log and two things being multiplied, you can change it into the sum of two logs. If they're being divided, you can change it into the difference of two logs. And if there's a power, you can bring that out in front of the logarithm. The other one that's always good to keep in mind that you probably have memorized by now is how to change from logarithmic form to exponential form. I'm going to keep all those in mind. If you don't have them written down on a lovely little card, you should. Hopefully they're in your brain by now. So let's take this first one. What I first notice when I look at this equation is that there are logs on both sides of the equation. This is important to notice because if that's the case and the base is the same, then you need to get this part to set equal to each other. If you can get the log of base 5 of something equals the log of base 5 of something, then you know those somethings are equal. So this is preventing us from doing that 2/3. So I need to use my rule and put that 2/3 back over here. And once I do that, then it's the log base 5 of this that equals the log base 5 of that. So I just set those two things equal to each other. So I say x squared plus 7 must equal 64 to the 2/3. And so I want to break this one down first. 64 to the 2/3. This 3 means cubed root. This 2 means I squared. So first I take the cubed root. The cubed root of 64 is 4. 4 squared is 16. So I'm going to rewrite this. And you could do that in your calculator. You could raise 64 to the 2/3 and it would give you that 16. Then I need to get x squared alone. When I have a quadratic equation but no x, no linear term, then it's easier to get the x squared alone and take the square roots of both sides. So I'm going to do that by minusing 7 from both sides, and when I do that I get x squared equals 9. If x squared equals 9, x must equal plus or minus 3 if I take the square roots of both sides. Well, I always want to check because sometimes one of them might not work. So if I put 3 in here, I get 9 plus 7, and that equals 16, which we know that 64 to the 2/3 was 16. And if I put a negative 3 in, that squared gets rid of the negative, and I get the same thing. So I indeed have those two answers. Okay, now you'll notice there are logs on both sides of this next equation. However, on one side there's a sum of logs. So since I have logs on both sides, I want to get one log of something equals on the other side 1 log of something. So I need to take these two logs and make them 1 log using my properties. The first thing I have to do is get rid of this. Remember that goes up front. So I have 3 halves here. And what is 9 to the 3 halves? Well, the square root of 9 is 3, and 3 cubed is 27. So now I have the log base 6 of 27. Since that's a plus, it's times whatever this is, those two being multiplied using my properties. So now, since I know I have the log base 6 of x, I know x must equal 27 times 2. And what is 27 times 2? Well, 2 times 7 is 14. Carry the 1. 2 times 2 is 4, 5. So it is 54. And next, you'll see on this next one that there are not 2 logs on each side of the equation. There are 2 logs on this side, and there's a minus sign in between. So I'm going to use my properties, the difference property, and change them into a quotient. And then I'm going to use my other property where I change from logarithmic form to exponential form to solve this equation. So it's important to recognize those things. So let's take care of these exponents, this exponent first. We know that it's 2 up there, so I have the log base 3, now this is a minus sign, so I have a division sign here. X squared, since it's on the left, goes on the top, and x minus 2 is going to go on the bottom, and that still equals 2. So I change that using my division or quotient rule. And now I'm going to use my changing from logarithmic form to exponential form. So it's 3 to the 2nd power equals that. So 3 squared equals x squared over x minus 2. 3 squared is 9, so I get 9 equals x squared over x minus 2, and I can cross multiply or multiply both sides by x minus 2, whichever you prefer. You're going to get the same thing. But over here then, I get a 9 times x minus 2 equals x squared. So simplifying that using my distributive property, I get 9x minus 18 equals x squared. It's quadratic, has a linear term. That means I need to get everything on one side. So I'm going to move these two over there. So 0 would be left on this side, and I'd get an x squared minus 9x when I move it over, and plus 18. And then I simply factor. And I know it would be an x and an x. And 18, let's see, I think 6 and 3 will work. 6 plus 3 is 9, and 6 times 3 is 18. Since it's a negative 9, both of them would need to be negative. So I get minus 3 minus 6. So my answers would be x equals 3 or 6. And then you can come back and check. If you put a 3 in there and a 3 in here, and we can kind of use this one as an example. 3 squared is 9. If I put a 3 in here, I get 3 minus 2, which is 1. So 9 divided by 1 is 9. 3 to the second power is 9. So that's correct. Now if I put a 6 in, I get 36 divided by 4. 36 divided by 4 is 9. And again, 3 squared equals 9. So checking is important when you're doing these, and that works. So keep in mind, when you're solving these logarithmic equations, make sure you look and see whether you have logs on both sides or whether you have just logs on one side, because it does make a difference on how you want to solve those. And this is M Squared signing out.